Hi, I'm Alfonso Lagares, and this is my Physics 2212 Lab 2 report. First, I'll introduce the lab, its goals, and the fundamental principles involved in it. I will then discuss the data collection and measurements taken during this lab. The result of the lab will be interpreted and presented through a closed script model. And finally, there will be a conclusion and a couple of questions. Focuses on the concept of charge and the interactions present between charged matter. The main goal for this lab is to find the excess charge on a piece of tape that has been charged through friction. This tape will be treated not as a point charge, but as a line of equal charges evenly distributed along the tape. The fundamental principles involved in this process are Coulomb's law, Newton's second law, and the concepts of superposition and numerical slicing. These last two are especially important to find the electric field caused by a line of charges, because they provide numerical methods to compute the resultant electric field from distributed charges. It was found that the tapes are positively charged, having lost around 1.2 times 10 to the 11 electrons. It was also found that this positive charge was larger than the one found in the first lab, which treated the tape as a point charge. In order to measure the amount of charge on one of these tapes, a charged tape was suspended in between two objects, and another charged tape was placed directly underneath it. The tapes were brought together slowly until the first piece of tape started bending outwards, meaning that the electric force on it was equal to the force due to gravity. This occurred when the two pieces of tape were 0.05 meters apart. This measurement was repeated 3 times to reduce random error sources. The excess charge on the tape was computed numerically using low script, which came out to be 1.92 times 10 to the negative 8 coulombs. Using this result, the total number of missing electrons on the tape was calculated. Dividing the total charge on the tape by the charge of a single electron, it was found that around 1.2 times 10 to the 11 electrons were no longer on the tape. The total number of atoms that formed the tape was also calculated, using the area occupied by an atom and the total area of the tape. This came out to be around 4 times 10 to the 17 atoms. This means that the ratio of electrons lost per atom of tape was around 3 times 10 to the negative 7. The results of this lab were modeled using GlowScript, a Python framework. Some assumptions were made to describe the physical phenomena. The tapes were assumed to not be affected by air resistance. It was also assumed that the tapes were formed by a line of equally charged point charges, evenly distributed around their length. The model produced the results on the right. As you can see, the gravitational and electrical forces canceled each other out when the total charge of the tape was 1.92 times 10 to the negative 8 coulombs. This charge, evenly distributed along the tape, cancelled out the gravitational and electrical force applied on the top tape, making it float. The script calculates this charge, iterating through all the point charges on the tape and using the principle of superposition to calculate the electric force needed to cancel out the gravitational force. Finally, modeling the tapes as a single point charge makes the process of calculating the charge on them simpler, but this assumption is too coarse for some applications. Modeling the tapes as a line of charges is a more accurate representation of the real phenomena. The net charge on the tape is significantly larger when considering the tapes as a line of charges. These estimated values differ because the point charge approach does not consider the even distribution of point charges along the tape, altering the estimated result. The value found when considering the tape as a line of charges is likely to be closer to the real value.